Here I'm going to do a demo of how to fine-tune a text-to-text generative model, specifically the GPT-Neo model from Eleuther AI, to create a text classifier. We're going to try it with both the 125 million and 2.7 billion parameter versions. We're going to use the student questions data, which is a whole bunch of test questions, about 120,000 of them, although I'm going to only use about 5,000 because we don't need that many for transfer learning, and this is also going to take a very long time if we used all 120,000 of them. Now, if I look at the data set we have here, I'm going to take the top 18 lines of it, which I know actually contain the information, and we see here that it's a regular CSV where we have a text and a label. Now, the text starts with the quotes, even though it's multi-line here, so we have all the way up to this section. An anti-forest measure is afforestation, selective grazing, clearing forests, selective felling, and that is a biology question. The same thing here, we have among the following organic acids, and then that's a chemistry question here. Then we have this question here, which is clearly a maths question. And then finally here, in this one, if we take the last of these quotes, we have another biology question. Now, I've created this data set. It's a subset of the main one. It has 5,000 of them. But what we're going to do is we're going to use a little application I've written in Python, which I will include a link to in the description below. And we're going to use it to convert this to another format that Clarifai uses as well. We are going to use this same utility to split the data set into a training and testing set. Now, here it is. This is subject questions short. Now, when I run the little utility, it does this. First, it asks if any columns have multiple values. We know they don't because there's just a single block of text and a single topic. It's either physics, chemistry, biology, and math. So no, enter the number of the column that contains the text. Now that's the first column, so we want 1. So it's already called text. And it notices that there are multiple categories for the second column. There's chemistry, math, biology, and physics. It's noticing that there isn't just one or the other, which would be binary classification. And it's automatically noticed that there's only one other column, so we're going to use label to be used as the labels column. Would you like to split this data set? And we're going to say yes, because we want to turn this into a training and testing set. Would you like to shuffle it? No, we don't really need to for this. And would you like to split the data set into training and testing or training, validation, and test data sets? I'm just going to say a training and test data set. What percentage of the data set should be used for training? I'm going to use the pretty standard number of 80%, and it automatically knows now that it's going to be split into 80% train and 20% test. And if I go here, this is the original CSV that it created, and then we have one called subject question short clarified train and subject question short clarified test. And they're not that big, 1 megabyte and 256K. So to do this, we're going to create a new app by going to Create. I'm going to use GPT-Neo Fine-Tune as the ID, and I'll put the same for the description. This is a blank app. Create. We're not going to be dealing with the model yet, because first we have to put some inputs. Now, it originally comes with a base workflow of general, which is intended for images. So we are going to change this to an empty one, so it doesn't try to do any pre-processing on our inputs as we upload them. Now I go to Inputs, Upload. Let's grab this, which is our training set. So let's pull that in and hit Upload. At this point, just for the purposes of the video, I've sped it up quite a bit. So to skip the whole uploading. And we're done. Now that our files have uploaded, what we want to do is select them all and put them into a training data set. We're going to apply to all the search results, so everything gets done. Now we're going to go to Models, and we're going to add a model, and we're going to build a custom model, and we're going to use a text classifier. We're going to try first the 125 million one. I'm calling it LLM 125 million with a training data set. Everything. And let's choose a template of the 125 million parameter LoRa template. This is LoRa, which is low rank adaptation, an efficient way to fine-tune these giant models. We're also going to fine-tune the 2.7 billion parameter version of the same model. So once again, we're going to choose the text classifier. We're going to give it the similar name of 2.7b for billion, choose the training data set, select all the concepts, and now we're going to take the template for the 2.7 billion parameter version of this model. Now we can look at the models, and these are going to take a little while to finish training. Of course, we can always advance the time. So it's been about 30 minutes, and we can see how well the fine-tuning went on both the 125 million and 2.7 billion parameter versions of the model. Let's try the 125 million first. We can see the versions of the model. We can see how it did. We can see all of the output that was given during the fine-tuning. And we can calculate some metrics on it by evaluating. And we can speed this part up as well. And there we see it finished, and we have our result, an AUC of 92.86%, and we can view it. And there we have the ROC AUC of 93, an F1 of 0.74, precision of 0.82, and a recall of 0.68. So not really that great. Let's see how the other one did. Now we're checking the evaluation of the larger model, the 2.7 billion parameter model. So the 2.7 billion parameter model has finished training, and we can see that we have a 99.07 AUC. Now these metrics were evaluated on the training set, so it's entirely possible we've overfit the data, which is possible with these very large models. We'll have to test it with the test data to make sure. And we see here we have 99, 93, 94, and 93, so much higher. And of course now we can evaluate a test set just like we did in our transfer learning video. Now I've not shown it here, but you can check the other video on transfer learning to see how I do this with a test set. But now we can switch to that test set after uploading it, of course, and labeling it as a data set called test. And we see our new metrics, which are going to be a little bit lower. So we have 98 for the AUC, 90 for the F1, 91, and 90. And that's how you can relatively easily fine-tune the 2.7 billion parameter GPT-Neo for text classification.